accepted officially now. So what hopefully you're looking at here is what our Canvas site looks like. Now, if you are on the wait list, which some of you might be, and you want to officially join the class, you don't, it's not automatic. You have to do some things. So if you're on the wait list, what you need to do, you'll get in, but what you need to do is send me your name, your student ID, and prerequisite proof. For most of you, that's going to be, I took 141 Olympic College and I got a 3.2, and here's a screen grab from Oasis to show it, right? That would work. And for some of you, I took a test. For some of you, I get placed into this class and here's a copy. Just take a, a photocopy, whatever you want to call it, and send it to me. And if you do that, I can get you to officially join the class, right? So if you're on the wait list, that's what you need to do. If you're already in the class proper, you don't need to do any of that because it's been checked before. I don't need to check it now. Now, what does this guy have? Right, there are 3 modules right now. The first one tells you a little bit about myself and welcome to the class. This one here is WebAssign. We'll click on it, show you while we're doing it. This class has got 2 main chunks of work. Homework and a lot of your assignments are in WebAssign. And here are the instructions that you will follow to go and join WebAssign. This is where you have to pay the money. You get 2 weeks kind of free grace, right? But at the end of that, you have to pay or they'll cut you off. You get an ebook, so you don't need to pay for that, but all your homework assignments and all that good stuff is going to be there. So that's important. The other half is Canvas, which is what we're looking at right now. Canvas mostly has resources. That's where I put all the videos. For instance, the video that we've got right now, probably with the exception of our dogs, will be there. I'll do a kind of editing and we'll be, you'll find that there. And you can get the link to Office Hour, which is 10 o'clock here, how to upload Microsoft Lens, which I'll talk about later, in a few weeks from now. A little fun stuff on some useful websites. This one here is pretty big. This is an important link. If I click on it, there's the link that you use to get to this class, the one that you're using to get to the one right now. And that'll be good for about 4 or 5 weeks, and then I'll have to change it because that's what Zoom makes me do. But if you click on week 1, in this blank spot here will be our first video. And it will be this class. And tomorrow's class and Friday's class, or in your case, I should say Thursday's class, because it's a 4-day week for you lot. They'll all be here. We're good. And why is that useful? Well, I hope it's useful because sometimes you're going to miss a class, right? You go to the dentist, your car breaks down, something gets in the way, you catch the flu. You want to check that link so that you can watch the classes that you missed. You want to get ready for your final, or you want to get ready for your midterm, right? You could go and look at some of the videos there. You might only want to look at a couple of videos. Oh, I want to see the video on trig identities, or I want to see the video on SOHCAHTOA. You would find the video, they've got little names telling you what the main topic on that day was, and you can watch that video and you're good to go. Any questions about what's here? Most of it you can look at your own time and tell me if you've got questions. Anything right now? We're good. Right. Now, that's one resource. If you go to class resources, I've got some more stuff. For instance, chapter 5. If you click on this one, here are videos of other people. Some of them are, for instance, he is one of our professors. And you click on that and you can find out about what's called the unit circle. And see if I can, there we go. If you click on this one and that one, right? Make it a bit bigger, you see? These are mostly from YouTube, but I picked them because I like them. I think they're good. And it's helpful to see someone else's approach, right? Because I may not always do it the best way. And so you get to watch a video on the same topic I like the way she said it. Right, that makes more sense to me. That's what it's there for. And there are also things like help on your homework. So here's some questions. And here, some pretty untidy solutions to it. So as you scroll through that, at the bottom, you've got some quite interesting programs. This is an online graphing utility. So you could type in y equals, no, hopefully it'll take sine, it should. There we go. There's y equals sine x. And you can zoom in and move it around, and you could put in another function, y equals x, maybe x take away, say a half. There we go. And you can click on it. If I click on it a bit better, there we go. And you can zoom in. And what would that be? What, 1.5, 1, right? You could find out where lines intersect. So that's a kind of cool little feature. Leave that one. And I think I've got one more. Yeah, the parametric one's kind of interesting. That one doesn't really come into play until quite later on, but it's kind of cool. You can graph polar functions. Come on. There you go. And I'm lazy. There, speed up. Kind of cool, right? So they're just resources. Some of your visual learners, and it's very helpful if you can see something rather than just have it kind of, you know, as a math thing to do, but nothing visual to see what's going on. So these are essentially resources that hopefully will be of some use to you. And the third thing here, which I'm not going to spend any time on, are college resources. This tells you all sorts of cool stuff that you can get from the college. For instance, you might need a webcam. You'll find out how to get a loaner on that. Now, if I kick over to the syllabus, when you want to contact me, will you use my email address, which is this one here? Now, you can do it through Outlook or you can do it through Canvas. It works fine. What I don't want you to do is in WebAssign, there's buttons that are like Ask My Professor. And I think there's another button that you click and you say, ask for an extension. Or you can click those buttons as much as you like. I'll never know because they don't send me that information, right? There's probably a way to set it up that I don't know how to, or maybe it's a bug they've never fixed. So if you need help on a question, just shoot me an email saying, I need help in question 4, section 2.1, or I need help, I need an extension on the time for my homework, and I'll do it that way. So just email me. We have officers at 10 o'clock. Here is a Zoom link for that. Just like a normal officer, you just turn up and I'll help. Basically, you can't take this class unless you've got a prerequisite. For most of you, it's going to be, you did 141 here, right? And you got a 2.1 or a 3.9 or whatever, and you're in. For some of you, you took an Accuplacer test. And I think some of you, I don't know how many, you might have got in because you of your high school. Well, thank you. I'll try and contact James and ask him how he made it work. But until then, keep using the email. In fact, it's kind of easier if I only have one place. So I'm kind of happy once we've done that. Where was I? Yeah. So you need prereq. If you don't have it, you can't get in, essentially. If you're in the class already, then there isn't a problem. If you're on the wait list, you got to send me proof of prerequisite, which is simply take a screenshot of your grade from 141 and send it to me along with your student ID, and then I can get you into the class. This link here you can use to get to techie free stuff like webcams. You don't need a textbook because WebAssign has inside it an ebook, which is essentially your textbook. So you don't need to buy a textbook. Here are some instructions on how to join WebAssign. I've got a bigger, more detailed version in Canvas, but this is a short version. Important dates. Monday the 17th is a holiday and Monday the 21st of February is a holiday. So we won't have class those 2 days. There's going to be a midterm on Monday the 7th and a midterm, or a final, I should say, on Tuesday the 15th. And then we come to this page. So that's my cue to jump over to WebAssign. Is it this one? Yes, it is. Okay, when you join WebAssign, it'll look something like this, right? And homework is due by midnight Sunday, essentially. Now, if you've not done WebAssign before, let me show you how it works. You click on this one, just as an example, and you get some questions, and you type in your answer, in this case, to 3 decimal places. And if you type in, I'll do the correct answer first. Give me a few seconds to get it. And to 3 decimal places, I believe it's 0.419. A bit of luck. Submit answer. If it's not right, it's because I can't count. Oh, I got it, right? Now, if you did the answer to 2 decimal places, it still accepted it. If you did it to 1 decimal place, it didn't like it anymore. Do you see that it's a little bit generous about rounding off? But always try and be accurate. That's just the safest thing to do, right? So you see 1 decimal place it never made it, the other 2 it did. And let's see if we can find, this one's not. So for instance, if you're in question 10, it's got to read it. If you click on that bit, it should take you to the ebook, although the ebook you can get to separately. And then you can watch videos and things to help you out. So it isn't just that it has questions that you answer, right? WebAssign's better than that. See, it's got, for instance, you can have situations where you can try another question, right? Give me another example. There are read it parts, there are watch video parts, right? So you have lots of opportunities. You get 5 shots at giving the right answer. So if you get one of those cross marks, you get 4 more to go, right? But after that, the question's dead. Now, I don't know where you're coming from. So for some of you, you're old hands at WebAssign, right? So there's nothing going on here that you really are worried about. Make summed up. Caitlin, you cool with this, right? Now, some of you have never seen WebAssign in your life, so you're going to be a little bit apprehensive. Caitlin, I'm putting words in your own mouth. Is it relatively easy once you've got over the first week? Or
yeah,
lesson?
WebAssign's pretty easy to use. There's nothing really too hard about it or confusing about like how it works.
Right. I would agree with that. I don't know if they've got a feature here. It's not happening on mine, but yeah, there's a bloody ask my teacher things. Don't do that. Yeah. Sometimes when you click, oh, that's the 3 decimal places one, right? No, I won't find it. Sometimes you click on the box, there's a little math thing over here because sometimes you have to do fractions and square roots and stuff, right? And the way you get that in is by, if I could find a question that needed it, I'd be able to show you, but you never find ones until you're, maybe that one. There we go. Right, I finally got a question where it appeared. They only appear when you need them. So let's pretend I needed this question. I would do brackets. I'm making up nonsense here, but it's 6/7, and maybe it's 6/7 pi, right? So hit the Greek letter, and somewhere in here, there better be a pi. There, you see how you type it in? Let's pretend it was a really weird answer, like the square root of all that. So if you have to do an exact value, something's a bit messy. Can you see this little calc pad? And now I know its name. Can be used to do pies and fractions and, oh, there, if you want to do an inverse sine, whatever that is, you would take that one. Are we good? Right. So let's return back to this. So the course is split into 10 weeks. Each week you have a certain number of assignments that you need to do. For instance, this week, our assignment is going to be these 3 sections. I've broke 6.1 into 2 parts, but that's just so that you don't get one huge section with tons of questions, and 6.2. And a guy called it online test. When you have finished week 1, this will not be in WebAssign until Saturday. But when you're finished and you've done all the homework and you're ready to take the test, you will click on online test 1, which is in WebAssign, and it will just be the same as the homework, right? You hit the box and you type in 4.123, right? And you got 90 minutes to do it. And you will get 5 shots, but you won't be told if you're right or wrong. So hopefully you're right. And if you don't like the answer, you can do it a second time. But whatever your last answer is, that's the one that counts. So when you've got an answer and you're happy with it, leave it. And then week 2, and week 3, and week 4, and then week 5. And once week 5 is finished, we have a midterm. But the midterm is going to be different. All the other stuff that you've done is all WebAssign, right? I don't need to see working. You'll have working, but I won't see it. But in the midterm, you're going to be at class in the usual time. And on Canvas, I will have a PDF that will appear and there will be questions there. And you will be doing your working on paper. And then you will use a program called Microsoft Lens or some other program if you've used it for other classes. And you will take copies for, basically use your phone, take copies of that, and you'll upload it into Canvas. And that's where I get to see it and I grade it. So it's a bit like the online equivalent of turning up for class. I hand you a piece of paper with the questions, you write the answers down in paper and you hand me it back, right? That's the analogy that I'm using here. And that's a biggie because that's worth a lot of your grade. And then you go on and do all the other weeks. And then the final exam is a 3-hour. I think I put in what the midterm is. If I didn't, I'll put it in here. No, it'll be later on. But the midterm also is going to take you a little bit longer. So it'll be like, for our class, what's it going to be? 1 to about 3. So it'll be a little bit longer. So you have time to finish it, essentially. And the finals 1 to 4, even longer. Learning outcomes, well, we're going to do trig, so you can read that in your own time. Don't cheat. If you have a disability, I need to look at it. Right, let's put the whole package together. Class is mandatory, you must come. 10% of your grade is going to be for turning up. So let me show you how I do attendance. If you go to the chat box, I want you to hit on that chat box and put your last name. So Caitlin, you're just going to type in the word trailer, right? And Aaron, you're going to type in Fowler. So everybody do that right now. I get a copy of this and I put it on a spreadsheet and it sucks out your last name and I do attendance. So I got 18 people so far. I know that's more, 19. Come on, who's missing? I mean, if you don't say you're here, then you're not here. And you've lost 1 day's attendance. Okay, a couple more kicking in, good. We go with that, that's how participation works. I'd like to see faces. Online is difficult for students. It's also difficult for me because one of the best things I get when I'm on ground is I get to see your faces, and your faces tell me a lot about what I'm doing. See, if Aaron has that deer in the headlight look, then oh, I'm not doing a good job of explaining this concept. If Caitlin does the subconscious nod, you know the nods that you don't even know you're doing, but your brain is saying this makes sense. Aaron's doing it right now, right? Because what I just said made sense to him because he knows what I'm talking about. That's how I get my feedback. If all I see is blank with a name, it's very difficult for me to know if I'm doing my job well enough because I want to help you and I don't know how well I'm doing my job unless I can see your face. Can you get my feedback thing? That's all I've got to work with apart from questions. So that's the main reason I want that. You must be visible during the midterm and the final, but that's security. I want to make sure that Kimberly's twin sister is not helping her with the final exam, right? Not that Kimberly has a twin sister, but even if she had, you wouldn't do that, right? But that's guaranteed. I need to have it for those. Right. Are we comfortable with how the participation? It's going to be 50 attendances, right? And it's going to be worth 10% of your grade. So if you only come half the time, you're going to lose 5% of your grade before you even do anything. There's our Zoom meeting that'll last about 4 weeks, and then we'll have to change it. WebAssign, 25% of your grade. Those tests that I talked about, remember by Sunday, you've got those tests. I think I haven't mentioned this, so I'm glad I've came back to it. When you're finished week one's homework, there'll be a test appearing on Saturday, and it will last all the way to Sunday. Whenever you click on that, a clock starts. You've got 90 minutes to finish it. It's the same thing like in homework, right? You just type in the answers. I don't need to see working, right? You do all that. But don't hit that damn thing until you're ready to do the test, right? Because you get one shot at it. It's no good, oh, I'm going out again. The clock doesn't stop. The minute you enter, it's like a bomb, right? It's tick, tick, ticking, and then it explodes. That's a bad analogy, right? But you get 90 minutes to get it done. So don't go near it until you're ready. But 20% of your grade is based on it. So you can see it's a biggie, right? You want to be good, you want to be ready for it. All tests, including your midterm and your final, you're allowed as many notes as you like. As long as it's physically written down, you can use it. So you want to have a formula sheet handy, you can use it. If you want to have some notes on a topic, you can have it, right? That's totally okay. So midterm, 15% of your grade, the final is 30% of your grade. And then there's 2.5% on extra credit. If you do homework and do not ask for an extension to the time, you'll get 0.25% added onto your grade. So it adds up as 2.5% if you did every single homework without needing an extension. Now, you might think that's not a biggie. Can you imagine that you got a 1.8? Won't that now make it a 2.0 and a bit? So you'll pass. So I guarantee somebody in this class, that 2.5%, you're going to be really happy it exists, right? So be efficient with your time. If you do that, you'll always have your homework done and you'll be great. Right, so here's your grade. You need an overall 75% to pass the class. You want to get really high scores. 95% or more gets you 4.0. That's what they look like in grade letter format. Places to get help. We have online tutoring. We have tutoring in the college, I believe. See me, shoot emails, WebAssign, Canvas has got tons of videos. I mean, there are plenty of places to get help, right? So you're not going to be left on your own, son. And the usual things that students who want to be successful do. Would you agree things like wait until 10 p.m. on a Sunday to start your homework's probably not going to end well? Right. As an example of what not to do, right? Do your homework as soon as you can. And that, to me, is the best way to be successful. Right, any questions? I'm going to close it off here and start the good stuff.
So for those, the online class tests, is that they open on Saturday and that's it?
They open on Saturday, but you don't need to do it on Saturday. You can wait till Sunday to do it. You could wait until 9 p.m. on Sunday.
Yeah, I was just wondering if it's possible to be able to do it earlier.
No, because it won't be done, because you won't know Friday's stuff until Friday's finished.
Yeah, exactly. I just try not to do stuff on the weekends.
Oh, I hear you. Sorry.
It's fine.
Get up early and do it before breakfast, something like that. You know, so your day's not too wasted if that's what it is. Right. Are we ready to get started then? Okay. Look over all this stuff. You probably don't know what you don't know until you've read some of it. And then you're going to say, oh, that doesn't make sense to me. Well, talk to me tomorrow and we can clarify it. Right, slowly trying to find out where the heck I am, and then we'll get started. I don't want that window. I like that window. Okay. Well, let's begin by something that sounds obvious, but is not. How do you measure an angle? What do you mean, how do you measure an angle? That's kind of obvious, right? Let's give you an example. Let's suppose you have your typical X and Y axis, and I'll make one of these lines on the X-axis, which we typically do, and I'll make the other one there. And I'll tell you what these are called in case you see them written anywhere. They're called arms. So these are called the arms of the angle, and I'd like to know the size of the angle. And you can imagine there's a thing called a protractor, not very accurate, but that angle is 30 degrees, just for argument's sake. No biggie there. If I did a different angle, I suppose I'll do one here. And you always start on the positive side of the X-axis, that's kind of convention. And then I have an angle going up here. Can you imagine that might be 110 degrees, right? Since I don't want to do two more of these, I'll kind of duplicate things up. Can you imagine that angle there might be, oh, what would that be, 270 and another 50? Might be 320 degrees. And so it would be that angle. And then this angle here might be 330 degrees. And do you notice that we typically have a convention about how you measure an angle? You always make the X-axis the first arm, and then don't you like a clock going backwards, anti-clockwise? And the amount it goes backwards, isn't that a measure of the angle? Now, when you use this system, typically, aren't all angles going to be from 0, which would be you start there and you don't move. So a 0 degree angle would just look like a line, wouldn't it? And if you went all the way around and back to the beginning again, wouldn't you finish in 360 degrees? Was that seem reasonable that angles are measured basically going x-axis and then turning like a clock anti-clockwise. And the smallest angle you can get using this would be 0, and the largest angle would typically be 360. And that's fine, that's a good start. There we go. Something that you might not have thought about is, why 360 degrees? I mean, we're in a decimal world, aren't we, mostly? Shouldn't there be 100 degrees from start to finish, right? Can you imagine you could do that? Wouldn't that guy there be 25? This one would be 50. That one down there would be 75, and this one going across, wouldn't that be 100 degrees? Couldn't we have measured it that way? Do you know, if we were starting today and deciding how to measure angles, we probably would have done that. But angles have been around for an awful long time. The idea of angles has been around for a long, long time. And the people responsible for 360 degrees were the Babylonians, for what you would essentially where Iraq is, right? Babylonians. Very, very interesting ancient civilization. And they had a very strange number system. The Babylonians didn't count in decimals, like, you know, tens, hundreds, thousands, which would all kind of assume everybody did. They counted in 60s. So if you wanted to say 76, you would say 160 and 16. You'd have a symbol for each, right? A weird way of counting. But not as weird if you think about it. Isn't 10 and 100 quite ugly numbers to divide with? I mean, there's not that many numbers that divide 10, would you agree? What, 2 and 5? I don't think 1 and 10 count. How about 60? 2, 3, 4, 5, 6, 10, 15, 20, 30, and 60. Isn't there a lot more ways of dividing? It was actually better for them. They're actually the same people who come up with a couple of other things that you have not thought about. Why are there 60 seconds in a minute and 60 minutes in an hour? Babylonians. They were fascinated with the passage of time and measuring stars and angles. They did a lot of really good stuff on it. But can you see the after effect is that we have weird number systems? You have 360 degrees in a circle. You have 60 minutes, right, in an hour, and 60 seconds. Do you know the Babylonians thought there were 360 days in a year? Because in their mindset, shouldn't there be 360 days in a year? Because a circle was like a year. It didn't take them long to figure out they were wrong, right? They knew that a year was longer than that, and they actually knew quite well how much longer. And they've had a really clever way of fixing it. They just decided that a year had 360 days. And then once the year finished, the next 5 days, or in a leap year, the next 6 days, were just a big holiday. They just did parties. And then they started the year off and had 360 days. Isn't that a cool way of fixing a problem that didn't kind of work? I don't know if they even had names for the party days, right? Where they just didn't do anything but, you know, had fun, but that was them. So we're comfortable with the degrees, and I told you a little bit of history, which you may or may not would be interested in, but that's not the only way to measure an angle. We're going to tackle it in a different way. And what we're going to imagine, not great, but I'll try my best. Is that you imagine a circle. It's called a unit circle. A unit circle is just a circle centered at the origin, whose radius is 1. And they measure angles this way. You start with that guy, right, the one that goes there. And then you get your other guy. And this angle here, the number that we use to represent this angle, is actually that green distance. Now you might say that's a kind of weird way of measuring an angle, but would you agree it's consistent? Would you agree the more you travel, the longer the curve is, right? Now, well, let's do a quick bit of math here. Would you agree that the circumference of a circle is 2 pi times its radius? Do you agree with that? And since the radius is 1, isn't the circumference of a unit circle 2 pi? So far, so good? There to there would be 2 pi units long, right? 2 pi times 1, 2 pi. Now, I'll put down here a little baby version of my unit circle. And we are going to measure this angle using this thing. And this system is called radians. I don't know if you've measured radians before, but that's what they're called. So, would you agree that 0 degrees, right, degrees, if you measured it using the radian measure, wouldn't it also be 0? Now, if I move to this angle here, would you agree that's 90 degrees? Now, if you do it as a radian measure, won't it be the length of this arc? Right, so if you were a little ant and you were crawling, how far would you walk from here to here? Isn't that a quarter of a circumference? And if a whole circumference is that, isn't a quarter of that a half pi? So can you see that a 90-degree angle is the same thing as a half pi radian angle? You see they're equivalent to each other, right? 90 degrees is the same thing as a half pi. The next one would be this angle. Would you agree that's 180 degrees? And what would that be in radians? Well, would you agree that from here to there is half a circle, and half of that guy is pi radians? The next one would be here, which is 270 degrees. Anybody want to have a guess what the radian measurement for 270 degrees is? $90 is half a pi, 180 is twice that, pi. What would 270 be?
1.5 pi.
Okay, and I'll call it 3/2 pi because that's the way we like to write it, but you're right. And wouldn't 360 degrees just be back to 0 again? So the first thing that we are going to be doing in homework is we are going to be looking at questions where we're going to convert from degrees to radians, and then from radians to degrees. Now, these guys we could do without a formula. Can we just figure out what the whole circle was and do fractions of it? But it gets a little bit harder when you have to do 22 degrees, right? Or how many degrees is 3/7 pi radians, you know, those kind of questions. So what we have are some formula, and I'll write them down. The first one, formula 1, is going to be how to convert from degrees to radians. So it's a bit like these guys here, right? I tell you 90 and you're going to tell me it's half pi. I'll tell you 180 and you're going to tell me it's pi radians. And here is the formula. R, I'll call it rad for short, radians, is equal to the degrees over 180. So if I tell you how many degrees it is, can you see you can plug it into this formula and that will be the equivalent for the radians. Somebody give me a nice whole number, but not one of these, and we'll do an example. Give me anything comes into your head.
30.
Okay, so let's do a 30 degrees, right? So in radians, 30 degrees out of 180 pi. If you're going to give me the exact value for radians, have you noticed that just by the formula, isn't it going to be some fraction of pi? Right, it's going to be a half pi, whatever that is. Now, do you think we should do anything about the 30 over 180? Would you agree it simplifies down to 1/6? Or pi over 6? Some people like to write it that way. I'm going to pick a really ugly one. 36 degrees. 36 degrees over 180 pi. Now, a little trick for you, especially when the numbers are really weird and you're not sure, can I simplify it, and you don't want to spend a lot of time to do it. If you go 36, oops, clear. If you go 36 divided by 180 on your calculator and you press enter, you see you get the answer 0.2. But if you then tick math and choice number 1, it'll turn your answer into a fraction. So 1/5 pi, or pi over 5. There we go. That you can actually let your TI-84 simplify fractions for you.
Can you show me that again? How you did that?
Sure. Let's pick a 36 divided by 180, hit enter, and then hit the math button, choice number 1, which basically says fraction. So turn the answer into a fraction is what that's kind of saying. And the answer is 1/5. Okay, random, 22 degrees divided by 180. Math button, choice number 1, go. There, 11/90. You see how easy that came up? So if someone gives you the question, turn 40 degrees into radians, turn 22 degrees into radians, if they want the exact value, won't this formula and a little bit help from the calculator if you want to simplify work quite well? However, sometimes these questions will say, give your answer to 3 decimal places, right? When that happens, you're going to have to change your world. Take this fella here, right? As an exact value, it's 1/5 pi or pi upon 5, but they don't want it that way, right? They want it to 3 decimal places. Well, if you go pi divided by 5, can't you round off the answer to 0.628? And that's how you'd get 3 decimal places. Are you good with turning degrees into radians, right? We've got a formula, it's a kind of plug and chug. Put the degrees, divide it by 180. If it's an exact value, simplify it, stick a pi at the end. If they want it to 3 decimal places, pretty much do the same, but then 1 extra step. Isn't the 1 extra step just turn that into a decimal? Are we good? Right. So that's how you turn degrees into radians. Oh, if you wonder where the 180 and the pi came from, can you see it comes from here? You're wondering where that formula came from. Right. Let's do the other way around then. To convert from radians to degrees. So how many degrees is the answer? DG. Any idea what the formula is going to be where I write it down? Because you could actually use this in a bit of math to generate it.
Radian times 180 over pi.
That'll work. 180 times radians over pi. Essentially what you said, I just like the number first. Does that make sense, that this formula from that one? Can you see how it would work? So it's, again, it's a plug and chug, but it's going to be a little bit uglier because it depends on the questions. Some of the questions are going to be exact numbers like 82 degrees, but most of them aren't they going to be 14.123, right? They're going to be decimals because they rarely come out good. So let me try one. Actually, you tell me one. Give me a radian angle that you want to turn into degrees. Top of your head, anything you like. Well, that's not the hardest question in the world because any answer is correct.
Pi over 8.
Okay, so you go 180 times pi over 8 divided by pi. So far, so good. Now, you could certainly do that on your calculator, and it would work quite nicely. So let me do that first, and then I'll do it kind of more algebraically. So clear this guy out, and bracket 180 times pi, which is its own button, divided by 8, close brackets. That's the top guy, divided by pi. And the answer is 22.5 degrees. Are you comfortable how the calculator did that? 180 times pi over 8, put brackets around it, divided by pi. Now, you could do this a little bit more mathematically. Wouldn't that pi cancel with that pi? So what you're left with is 180 times an 8, which is also 22.5 degrees. Let's try a really ugly one. I'd like to know how many degrees 2 radians are. Radians don't need to be multiples of pi. Very often they are, but they don't need to be. So if I tell you that it's 2 radians, can you see that's my calculation? Would you agree that this guy is just going to be an ugly decimal, right? So let's see what we get. 180 times 2 divided by pi. And to 3 decimal places, 114.592 degrees. So 2 radians is about 114 degrees. I wonder what 1 radian is. Well, it's 180 times 1 over pi. So 180, I know you don't need to do times 1, but I've done it now. And the answer you get is 57.296 degrees. So if you are doing a very kind of rule of thumb, isn't 1 radian about 57 degrees? Does that seem kind of make sense? 2 radians is double that. I bet you if you doubled that, you'd get this guy, right? 3 radians would be treble that. 4 radians would be 4 times that. It doesn't take you too long before you reach the end of the circle, right? And you don't need to focus too much on those. Are we good with converting things into radians and now converting things into degrees? As long as you got those formula and a decent calculator, shouldn't your life be easy? Okay, I'm going to give you a couple of questions just to try out. Just, you know, for you to check you know what to do and for me to be comfortable that you do. So I want you to turn 72 degrees into radians. And the second question is I want you to turn pi over 12 into degrees. And if you do those two guys correctly, then I'm happy, and we'll spend a little bit of time after that looking at what the homework looks like. Okay, last few seconds. Okay, here goes. Let's do the 72 degrees into radians. So it's going to be 72, 180, and tagging a pi. And since I haven't mentioned to 3 decimal places, that means, and the homework means this as well, they want exact values, right? So they don't want 18.1234 or anything that looks like that. So I'm going to go to my calculator, and I'm not going to do anything except the 72 and 180. And I'm going to see if the calculator can simplify that. So we get that guy, and then I go math choice number 1, and the answer I get is 2/5 pi. If this fraction does not simplify, in other words, when you do it in the calculator, it comes back as 72 1/8, then doesn't that make this the answer, right? There's nothing else you can do about it. Right, this fella here is going to be 180 times pi over 12 divided by pi. So remember to put the bracket around it. And 180 times pi divided by 12, close the brackets, then divide by pi again. And the answer was a nice 15 degrees. Looking good? Now, I am going to do a deliberate mistake. Do you know this answer has brackets around it? Let's see what happens if I don't put brackets around it. 180 times, it might work, I don't know yet, but it might not. Okay, so basically the same calculation, but without the brackets. Oh, okay, it worked. But there are other calculations I have done in the past that if I don't put the brackets, don't you get the wrong answer? It's to do with order of operations. I always work on the under the system that I'm going to screw up. So I put brackets in, even if I'm 90% sure I don't need them, I still put them in, because isn't that just safer? Because do you know the one time I forget to do it, isn't that the one question that actually did need the darn things? And you end up with the wrong answer because of that, right? So Just from my experience, I found that to be helpful.